So once again, I want to welcome everyone to tonight's webinar, Fire Weather 101. I'm Joe Deli Carpini, the Science and Operations Officer, and with me tonight, two of our meteorologists, Rodney Chai and Bill Leatham, who will be taking you through our fire weather program. So with that, Bill, I will hand it over to you to get started.
All right, thank you very much, Joe. So here's an outline of what we're going to be chatting about tonight. So the first thing, we're going to get into the basics, a little bit about the fire triangle, fire behavior, and drought, how we message, the NWS message and support our fire weather partners. And then we're also going to take a quick look at a case study of some wildfires across the U.S., the effects of wildfires, get into a little bit about fire safety, and some additional resources for folks to take a look at. So here's a list of a few, not all of the partnering agencies that the Weather Service has. This is kind of a focus on our area, and there's even more than what's listed here. But here's a couple of the big, bigger folks that we interact with: the Eastern Area Coordination Center, the National Interagency Fire Center, and then you could see the other ones that are listed. But the bigger one, would be the Northeast Fire Protection Compact for our area. So when it comes to fire weather and fire in general, you need there's three key ingredients, and you'll see here in a second that we probably use this triangle too much, but we use this triangle multiple times. But the big thing is you need for a fire is oxygen, you need a fuel source, and then you need heat. And as you can see in our text there, each year we have more than 100,000 wildfires across the U.S. If you looked on some maps right now, you could see that there's actually a fire burning somewhere in the U.S. But for a fire to be present, you need to have all three of those elements. If something's removed, then the fire will go out and won't persist. And so, like I kind of alluded to, we like to use the triangle maybe a little bit too much. But when it comes to fire weather and the behavior of fires, there's the fire behavior triangle. And the three things that are focused on in that are the fuels, topography, and the weather. Now, the things that the Weather Service that we focus on the most would be the weather and the topography aspect, because that's something that we are, especially the weather side of things, where we're more experts. When it comes to the fuels, that is something that we also look at, but as you can see in our text, we really rely heavily on our state fire weather state fire partners to get an idea of the fuels on the ground, to see if they're primed and dried out enough where there could be fire weather concerns. And that's where we talk to, there's some folks known as fire behavior experts, where they kind of have a really good feel of the fuels on the ground. So this slide it's very complicated, and I'm going to spend a minute or two on this one. But one of the big things when it comes to fire is terrain plays a pretty big influence into how fires spread and which areas are more susceptible for fire activity. As a general rule, when you have a lower elevation, the fire season's usually earlier, because the snow season ends earlier. There's less moisture, and because there's less moisture, the fuels that are in that area tend to be lighter. And what that kind of means is that they're able to dry much quicker than a higher elevation, where the opposite is what happens, where you have a fire season that's later. There's more moisture available, and the fuels tend to be heavier, which means it takes longer for them to dry out and be really primed for fire to happen, or for the fire to be able to spread. And then another thing that we look at is the slope, which you can see in the top left-hand corner. Now, what tends to happen for fires is the higher the slope, the faster the spread of fire. And that's mainly because what happens in this scenario with the higher slope is you get more preheating of the fuels ahead of the fire, mostly due to sunshine, but also due to the fire that's warming up things below it. And you actually tend to see, usually you tend to see fires be worse when they start at the base of higher terrain. So the lower in elevation the fire starts, usually the worse the fire is versus if it starts a little higher up in elevation. Another thing we look at is aspect, which is on the right-hand side of the slide here, and that is just your cardinal directions: northwest, east, and south. And when you're looking in a terrain situation, typically the south and southwest facing slopes receive more sunshine, so the fuel temperatures tend to be higher, and the lighter the fuels are, and that allows things to dry out quicker, and then also the snow melt happens earlier in the season, and that's usually areas that are more favorable for fire spread. When it comes to the north-facing aspect, you receive more shade, the temperatures are lower, the humidity is higher, and there's heavier fuels and higher fuel moisture. However, during certain burning conditions, these areas can actually also have an increased fire behavior. When it comes to the east and west facing slopes or west facing aspects, for the east, the heating starts in the early part of the day and there's cooling during the afternoon and evening. And for the west, the heating's in the later part of the day. And this is what we're starting to look at into like mountain and valley circulations. But these east and west facing aspects really depend, for the fire spread, depend on local factors and the time of day. And then you can kind of see in position, like kind of alluded to it a little earlier, was that, you know, the lower in elevation you are, there's typically lighter fuels and they can dry out a little bit faster than things as you go higher in elevation. And you know that it's usually the lower the fires that start out lower in the position or in the terrain that spread the fastest. So even though, you know, the topography, you know, you hear about all the worst wildfires across the western United States, but we do have some topography across southern New England where it's important for if we get any wildfires that get going, and you can kind of see the Worcester Hills on the map, and then also you get into the Green Mountains in western Mass and into Vermont, the Vermont area. So we do have some terrain to deal with even in our area that can cause, you know, some of those terrain-induced fire behavior things going on. So one of the things that we look at for when there's a higher risk for fire weather is when we're seeing precipitation deficits or more drought conditions, and there's a lot of different things that go into drought. But as you can see here, this is the latest drought monitor from last week. We'll have a new one coming out on Thursday of this week. But you could see, you know, for southern New England, a good portion of the area is abnormally dry right now. However, the big beneficial thing, at least when it comes to fire weather risk, is we've had a lot of rainfall in the past, you know, since this outlook's been released. So wouldn't be surprised if that abnormally dry started to erode away a bit across southern New England. But if you look across other parts of New England, especially northern New England, where they've got moderate drought, you know, that could be an area where, depending on the rainfall that they get, that there could be a concern for fire weather. So this is a look, this is another way of looking at how severe a drought is. And so this is called the long-term Palmer Drought Severity Index. And what this is trying to show us here is how much rainfall is needed over a week to end a severe drought. And the different colors are how much rainfall is needed over that period to reduce the drought. So if you look in our neck of the woods, you could see that the precipitation values, and this is on May 1st, we needed anywhere from a trace to 3 inches of rainfall, and maybe some parts where we're getting up into like 3 to 6 inches of rain needed. And a lot of our area actually did receive a real beneficial rain since the 1st. But if you look at other parts of the country, like California, especially Northern California, most of California, you're getting anywhere from 6 to 9 or even up to 12 to 15 inches of rain to really alleviate the drought conditions. So, and so here's, when we're talking fire weather, usually, one of the bigger things we look at is how much precipitation, or lack of precipitation specifically. And so the image on the left is the amount of precipitation over a 3-month time frame. And if you look over that time frame, much of southern New England was near to below normal precipitation wise, and that's a percentage of precipitation. So the warmer colors are saying that we're below 100%, and if you start to get into the green colors, that's when you're above normal precipitation. But since we're generally in that like lighter orange color, that's kind of closer to normal, if not just a little bit below normal. When you compare to the latest month of precipitation on the right, you could see that much of the region, except for Maine, northern Maine, we're above, if not well above normal precipitation with 125 to 150% of our normal precipitation for that period. So this is a look at the historic distribution of 100+ acre fires per forthcoming week, and this is across the eastern U.S. And on this one, it's just kind of showing the forecast weekly values for the number of 100+ acre wildfires, and you can kind of see that we're falling, like the solid red line is where the 50th percentile is, and we're kind of at, if not a little bit below, what the normal, or what they're saying is the median, the black line. And then if you look at the higher end of what the forecasts are, it's saying that we're a little bit above, but we're really generally falling in that green area, which is within roughly normal for this time of year. And I don't know if Rodney had anything else to add on this one from what I said there. So.
No, I think, Bill, I think you covered it very well.
Okay. And then I just grabbed this from the other day. So the folks at the fire center in Missoula, Montana, at one of the behavior researches, they put these out from time to time of the observed fire danger across the U.S. And you could see on May 9th, across New England, we were within the moderate fire danger based on the research that they're doing. But if you look at other parts of the country, especially the Carolinas or the southwestern United States, you're starting to get into very high to, if not extreme, fire danger across those states. But for our area, generally low to moderate fire danger. Another outlook that the National Interagency Fire Center puts out is kind of a look a little bit further in the future, kind of like the Climate Prediction Center, where they look at the fire forecast for the upcoming months. And if you look for May, for at least for May and June, the fire potential is normal for this time of year for up in our neck of the woods, and same thing for June. But you can see that the concern is mainly across the southwestern U.S. and then when we get into June, more into to California and the western United States. So taking a look, we talked about the eastern area, the Eastern Area Coordination Center's outlooks, and so they take actually a look at their eastern area covers from the upper Midwest into through the Great Lakes into the Northeast. And this is some of the things that they look at when they're providing outlooks for what is called the eastern area. And one of the key indicators that fire weather experts look at when deriving the seasonal and weekly outlooks is the soil moisture anomaly, because it kind of tells you how dry the ground and the fuels, potential fuels can be. And if you look for April, there were some concerns up in this area, given that we had some below normal soil moistures. It's saying it's roughly 20 to 40 millimeters of deficit, but luckily, due to recent rainfalls, and you can see on the right-hand image that some of those warmer colors, which is showing the below normal soil moisture, starting going towards normal, if not, closer to maybe above normal in some parts of the east. But you can still see that there are parts of the eastern area where they do their outlooks where there are concerns for severe fire danger risk. But at least for southern New England, since more rain is on the way, this should help keep the risk of severe fire danger to low. And then again, looking more into precipitation, if you look on the top left-hand corner, here's the accumulated precipitation over the last 7 days, and you can see much of southern New England, anywhere from 1 inch to 2 inches in spots, which if you look at the next 7 days forecast, we're still expecting more rainfall, and there could even be some thunderstorms in there, which could bring higher amounts than are indicated on that forecast. But then if you look the previous 14 days percent of normal, the colors that are cooler in this case are showing that the precipitation is above normal, whereas the warmer colors, like if you look at over Minnesota, it's been very dry. But in our area, since the precipitation has been much higher than normal, that would reduce the fire risk, which makes sense when you look at the fire danger map for May 10th. You can look at much of southern New England is near low, as opposed to say Minnesota, where they still have a moderate, if not high, risk of fire danger due to the lack of precipitation. And then here, again, kind of looking, even further out in the future for temperature and precipitation outlooks. When you look at May, June, and July, the forecast is for temperatures to be above normal, whereas May, it's right around normal, if not a little tendency for above normal. And then for August, not much of a signal for our area. But when it, again, kind of the precipitation being the big thing for May, it looks like they're thinking there could be a little bit wet across the upper Midwest, but our area kind of around normal precipitation wise. And then if you look at the other months, June, tendency for above normal precipitation based on the outlook. And then July and August kind of closer to normal, but if you can see in the text there, it's saying that we're biased because usually that time of year we're getting moisture off of with the Bermuda high coming in, so that keeps us usually a little bit more humid, which would reduce the fire danger. And then this is an excerpt from the Eastern Area Coordination Center's outlook, and you can see that near normal fire potential across the eastern area, which again I said is from the upper Midwest through the Great Lakes into the Northeast for May and August. However, if there aren't wetter conditions that develop, then parts of the Great Lakes and New England from May into June may have periods of above normal fire danger, and that's and that could carry over into the summer. But luckily, as we've kind of seen, we're starting to get some more precipitation. So our area should have lower fire danger, but as opposed to parts of the country like the upper Midwest, where things have been relatively dry, and if they continue to get dry, the risk will be higher. So looking a little more into what the Weather Service provides when it comes to messaging for fire weather, there's a couple different levels that we message it. The first here is showing the Storm Prediction Center. They don't only do severe weather outlooks, they also do fire weather outlooks, and theirs is more larger scale outlooks pertaining to favorable conditions for fire spread. Now, we do coordinate with the Storm Prediction Center on the fire outlooks, but they're looking on a much broader scale because they're doing it for the entire country. And you can kind of see on the right-hand side here with the image what an outlook might look like, where you see that they have elevated fire weather concerns across New Mexico and to California. So when it comes to our office, there's a couple different ways that we message fire weather. Now, there's a routine fire weather planning forecast that we issue around 4 a.m. and 4 p.m. unless there's conditions that warrant us to update the forecast. You've probably seen a few times we issue special weather statements when we have elevated fire weather concerns where conditions are near red flag, which I'll go over a little more in a moment. And then those special weather statements are coordinated with our state fire weather partners in Massachusetts, Rhode Island, and Connecticut. And then we also get into when we're concerned about, where there might be a bigger risk of fire weather across southern New England, is the fire weather watch and red flag warnings. And that's issued when we have critical fire weather conditions that are expected. And that's also at the request of state fire officials. And then lastly, when we're getting into, like, if we've got wildfires or something that's called a prescribed burn, we issue what are called spot forecasts, which are really just right wherever that spot is we issue a forecast. Basically, like if you kind of look on our page and do the point and click, it's kind of similar to that, but we're really honing in on that specific area. And those are issued by state fire, and when it comes to fire officials, for prescribed burns, hazmat incidents, and wildfires. But there's a lot of other things that we do with the spot forecast besides the fire weather. And then you can kind of see on the right hand side there, that's an image of what the fire weather planning forecast looks like. So to go more into, we're talking about the special weather statements. Well, the red flag warning and the fire weather watch. So the fire weather watch is what is before the red flag warning. There's no red flag watch, it's a fire weather watch. And it basically is an alert for land managers and also, mainly the land managers, but also the public, that weather conditions could result in extensive wildland fire occurrence or extreme fire behavior. A watch means that critical fire conditions are possible but aren't imminent or occurring. So that's kind of where you'd want to be prepared stage and kind of be ready. And we'll go more into preparedness a little later in the webinar. And then a red flag warning is the opposite, where critical fire weather is ongoing or expected. And they're either occurring now or will be shortly. And so that would be a situation where, like, if you were doing like a campfire or anything like that, you want to avoid doing that kind of thing. And you want to be very careful with any kind of burning going on. And in that case, that would be where you take action. Now, when it comes to our office, now this is different for different parts of the country, but for southern New England, you can see on the table below the fire weather watch and the red flag warning, this is what our red flag criteria is. And so the cured and pure pre-green up is before things start really get growing, usually in the springtime, before things start growing. And what we need is relative humidity below 30% at any time of the day, a sustained wind or frequent gusts greater than 25 miles an hour, rainfall less than a quarter inch in the past 3 days, and then as always is the case, no matter what product we put out with a special weather statement, fire weather watch, or red flag warning, we get information from our state fire weather contacts. So once the grass starts growing and other things are in the green up stage, the criteria is very similar, but the only thing that's added to it is there's an index that we look at to kind of get an idea of what's going on with the fuels. It's called the Ketch Bigram Index, and if it's 300 or greater, that's when we have the potential of putting out a fire weather watch or red flag warning. But again, the big thing, at least for us, is really getting input from those state fire weather contacts for determining what's the best course of action to go. And so here's a look over the since 2006, past several years, of the number of red flag warnings our office has issued. So you can kind of get a look at years where the fire weather may have been more active than others, where you have more red flag warnings, such in 2006 or in 2012, where there were 10. But you can also kind of see what Joe was talking at the start of our talk is, our big fire weather season out in New England is in the springtime, and then you can kind of see it again in the fall with those few red flag warnings out there. But those are the 2 times a year that we're mostly concerned about fire weather. But we are looking at it all times of the year. And then to kind of talk a little more about the spot forecast. So on the left-hand side is an image of kind of what shows the different forecasts that people are requesting for. They're issued at the request of public officials, again, for supporting wildfire, and then there's prescribed fire operations. And basically the prescribed fire operations are usually burning fuels or brush to basically cut down on wildfires ahead of time. And on top of this, we also use this for other incidents like search and rescue, marine, if there's something going on, like a marine incident, hazmat, and you could see on the right-hand side, you can see these online, but you could see kind of what these spot forecasts look like. These are emailed to the folks that send those requests in. And then last but not least, and Joe may know more about this, I know in this part of the country, there aren't too many incident meteorologists, but in the National Weather Service, this is a voluntary program that folks can join that are trained to specifically support fire, like a fire weather incident on site. So some of those bigger wildfires that you may see on the news out west, they're especially on the larger wildfires, that they may have one or several incident meteorologists out there to provide weather support for the folks fighting the fires. And they do that continuously through much of the events, or much of the different events. And as you can see here, they can actually serve up to 14 consecutive days before they're relieved by another incident meteorologist. And they actually work, they work extremely long days in really, really harsh conditions. I knew an incident meteorologist, and they were saying they work 18-hour days, and then you're back up again at it for 14 days in a row. And they help the fire control specialists from federal, state, and local agencies by interpreting the weather information and assessing its impact on the fire, and also coordinating with the fire behavior folks to kind of get an idea of how the fire is going to spread and where best to kind of put personnel to keep them, one, safe, and then also to help fight some of these bigger wildfires. And with that, I'm going to pass it on to Rodney to talk about, well, he was actually, you were out in the California area during this time, right?
Yes. Okay, so thank you, Bill. So like Bill said, I was actually in California during the 2018 wildfire season. I mean, by no means it was the worst wildfire season for California, but it was still very disruptive. In total, there were almost 2 million acres of land burned. And if you are wondering how big is 2 million acres, basically you take Rhode Island and Delaware combined together, that's about 2 million acres. And then there's almost 8,000 incidents, and unfortunately 100 fatalities, and over 20,000 structures being destroyed or damaged. And this is a look at the the biggest wildfires for California that year. The Mendocino complex was the biggest one. Had just over 400,000 acres, and then followed by the Carr Fire and Camp Fire, Woozy Fire, and then we'll take a look at some satellite images that shows just the sheer extent of these wildfires. So we'll take a look at the Camp Fire, which ignited November 8th in Northern California. It basically blew through the town of Paradise and became the deadliest and most destructive fire in California's history. And the following graphics are courtesy of Washington Post. So this is before the wildfire, showing a part of the town of Paradise in Northern California. And this is showing after the fire basically ravaged the town, and you can see widespread damage. It's very unfortunate, and this is basically taking the difference between the before and after image. The orange shows the buildings that were destroyed. So basically, almost 90% of the buildings and houses that you saw in the picture were unfortunately gone. And taking a look at the satellite image, so the following day, so you can see the smoke coming out from the campfire. That's that's the town of Paradise, and you can see just strong offshore flow. So in this case, the wind was blowing from the east, and basically it's spread well into the Pacific Ocean. And I put in Monterey just to show you where in relation to the town of Paradise. It's pretty far away. I mean, it's like you're talking about hundreds of miles. And then towards the bottom of the image, there's a Woozy Fire, and by no means it's small, but it's compared to the campfire, that's much smaller. But still, you can see how the smoke just blew over the ocean. And I signed up for the Monterey Bay Half Marathon, and which was supposed to be held on November 11. So when I showed you previously how far Monterey is compared to the town of Paradise, so unfortunately the smoke blew all the way into the Monterey Bay and created hazardous air quality. And the race organizers actually have to cancel the half marathon at the last moment. But compared to what the people from the town of Paradise went through, this is just really a small inconvenience. But I just wanted to show you how even though you're hundreds of miles away, the wildfire could have a direct impact on your life. So this is not actually from 2018, but from 2020. So this was last year, and the reason why I wanted to show you this is because look at the date. So that's August 21st, 2020. So that is not a month that is typically associated with wildfires in the state of California. Usually the dry season kicks in. I talk about like September, October, into early November. That's the prime season for wildfire in California. So last year, the state of California had, basically an just unprecedented early start to the wildfire season. And you can see just each of those orange dots, that's basically individual hotspot for wildfire. So you can see, it's not an easy image to view because pretty much the state of much of the state of California is, it's burning and engulfed with wildfire smoke. And this is taking a look at the LNU Lightning Complex fire north of San Francisco. to August 25th, 2020. If I'm not wrong, this was associated with a thunderstorm that came onshore, came right onshore north of Monterey Bay and south of San Francisco Bay, and those dry lightning, basically started wildfires, and so you can see the burn area in this image appearing in reddish brown, and the vegetation appearing in green, and of course those lighter white colors, those are wildfire smoke, but you can see how the extent of the wildfire damage. And there are weather models that we are familiar with, like the GFS, the European. What is this? You're looking at is the high resolution HRRR model, and so basically there is, because of its high resolution, one of the use for the HRRR model is to actually forecast the spread of the wildfire smoke. And you can see that at this instance, that's the origin of the wildfire in Northern California. And notice how the smoke basically spread all the way across the northern Great Plains, through the upper Midwest, and all the way into the Mid-Atlantic states and even parts of southern New England. And some of you may remember around that date, late August, there were a few days of vibrant sunsets, and that's actually associated with the wildfire smoke that originated from California. And those smoke basically get carried in the jet stream about 18,000, 20,000 feet above sea level, and then gets kind of blown across the continental U.S. So, that's basically suspended in the upper levels of the atmosphere, which gave us the vibrant sunset. So taking a look at the percent of normal monthly precipitation for October 2018 across the U.S. And so that's the month prior to the 2018 wildfires in California, which were in November 2018. And you can see that the brown, how much of California is so much below average in terms of rainfall. And unsurprisingly, that helped to contribute, to just the sheer intensity of the wildfires. I mean, it's not the only reason, but it is a contributing factor. And so basically, this is looking at the 2041 to 2070. So the red basically represents areas that are expected to receive more wildfires in the future, and 2041 to 2070, that's basically what is going on here is that, in those years, these areas are expected to receive more wildfires than what we are seeing right now. You can see that much of the northern Great Plains and the upper Midwest are expected to receive more wildfires. And part of the contributing factor is that these areas are expected to receive less rainfall in the future compared to now. And then there's also a secondary area in the Appalachians, and as well as parts of the East Coast. And for us here in southern New England, no big indication of whether we're going to get more or less wildfires. So it's kind of like a toss-up. So that's why we are in gray. And this is basically a loop of showing the drought conditions from July 2019 to August 2020. And the orange colors and red colors that represent severe and extreme drought. Yellow represents normally dry conditions. And so, taking a look at the firefighting costs in the area burned in the U.S. since 1985, you can see that's actually an upward trend over the years. And that orange line is the areas burned, and the black line is the cost of fighting the wildfires. And looking into the future, the fire seasons are expected to get worse as climate change increases the number of fire-friendly days, and also with urbanization and the buildup of houses, clearing the forest, that also increases the threat of damaging wildfires. So switching gear to let's talk about wildfire safety. And as Bill has mentioned, and he has done excellently, he has talked about the difference between a fire weather watch and a red flag warning. So a watch, pretty much like winter storm watch or severe thunderstorm watch, is to be prepared. And warning is, time for preparation is over, take action to mitigate the risk. And some of this advice is maybe more applicable for people living out west, like in California, but it never hurts to be to over prepare, instead of under prepare. And if you live in a wildfire prone zone, be sure to create a defensible space by clearing brush away from your home, and be sure to put together a basic emergency supply kit. And I'm not going to read off the slide here, but you can see those are the basic essentials. And be sure to know your escape routes, and make sure that everyone in the home knows the plan of action. And be sure to review important documents, including insurance policies and IDs. And also a great website is rady.gov, G-O-V, if you're interested to find out more. And so the image on the right-hand side, that's again, that's might be more applicable out west when they have really mountainous terrain. And part of the in the aftermath of I remember, we talk about the Paradise wildfire and just the very bad wildfire season in November 2018. And, the wet season, the rainy season came right after the wildfires ended. And, and the winter of 2018, 2019 was actually very wet for the state of California. But because there was so much land that were burned, especially in the mountainous terrain, there were numerous mudslides and, flash flooding, exacerbated by the loss of vegetation on the steep terrain. And so there's a lot of erosion, and there was just really a lot of road closures because of the mudslide. So it's just kind of like, it's almost, putting salt on the wound. You really have to suffer through the wildfire, but then when the rainy season came, you have to deal with mudslides and just never ending suffering. So it's very unfortunate. So talking about air quality issues, obviously with the wildfire smoke, you have worsened air quality, and we use the EPA National Ambient Air Quality Standards, and two of the most prevalent indicators are the PM 2.5 and PM 10. And so if you go to the EPA website, air quality website, there would be, you will notice that this two particular matter would be monitored, and you can use the table to gauge how good or how bad the air quality is on that day. And this GIS map, say here, shows most of eastern U.S. in green, which is good air quality. And we do also issue air quality alerts, AQA, from time to time, and that's usually issued at the request of the State Department of Environmental Protection, be it Massachusetts or Connecticut DEP or the Rhode Island DEM, Department of Environmental Management, for unhealthy levels of ozone or particulate matter. And as Bill mentioned earlier, they are the experts of air quality, and we kind of like are the messenger, but we do coordinate with them and make sure the message gets sent out. And these two pictures basically shows you, and they're taken by Bill. On a clear day, there's blue skies, and that's the radar dome. And when there's wildfire smoke, you can see the difference in the sky color, and just the visibility is very poor. So some of you may have heard of what is called a high split model, and basically computes the trajectories of air parcels, and as well as the transport, dispersion, and the deposition of the particulate matter. And the image to the right tracks the origin of an air parcel that moved into southern New England. So you can see on the right-hand side, there's a star and J, and then where Joe has the cursor, that's how the air parcel has moved, or it has been projected to move over the past few days, and then eventually ending up in southern New England. And these are just some of the resources that you may find useful. You can go to our website, weather.gov/BOX/fire. There's a lot of useful resources there, and that website, if you want to remember just one website, use that, and you can go to navigate to the bottom websites from our website. Okay, so I will pass it back to Joe.
All right, thanks, Bill, and thanks, Rodney. Great presentation. So we've got some questions in the chat, so let's go through them, and then we will move on to our weather briefing for tonight. First one is from Eric, and he asks, on the WFAS fire map, Virginia was mostly low risk for fire, but had two small circular areas with higher risk. What would cause that? Is that the particular terrain? And I think, Bill, that was in your section. I think that was the case, but you may want to expand on that a little further.
Yeah, so I'm just trying to take a look at the image again here. Yeah, I do see the two higher areas. That does look like it's within the terrain, but what it might also be is they may have stations that are right in that area, which may be more helping indicate more of what the risk is there, as opposed to maybe they have different information that's a little further away. But I would think it's probably due to the terrain, but I can't. I'm not the expert on for Virginia. I'd have to take a look at how they're how the conditions are right now too.
Yeah, I think that's the case. It incorporates some like different stations too. So sometimes you'll see a couple of dots or blips kind of blended in, but it could be due to some terrain as well. So yeah, good catch there, Eric. Let's see, from John, can errant lightning strikes spark fires in southern New England? I guess
yes.
Yes is the answer. Rodney, do you want to expand on that a little bit?
Yeah, sure, Joe and Bill. That actually is one of the leading causes of wildfires, because going back to what remember Bill mentioned the fire triangle, and one of the key one of the factors is you need a spark. And dry lightning, so when you have lightning, without either without any rain or very little rain, that can be a spark. And if you have dry vegetation, it can cause wildfire to spread pretty quickly. And and the example that I gave you, August 2020 in Northern California, that wildfire was started by a dry lightning. And believe it or not, if you go back to to the archives, there was actually a severe thunderstorm warning, which was very rare for August in California. And within 24 hours, there was a raging wildfire through Northern California. So it really shows you how, having dry lightning can get fires to spread out of control.
All right, and okay, next two questions are kind of about the smoke being carried across the country. So we can kind of combine these from John and from Alexander. So John is asking, as smoke is carried across the states, what causes the sinker rise? And then Alexander wants to know if we can see smoke from Honolulu. And I suppose it's possible. A lot of the times, we see the forest fires from southern Canada quite a bit, the upper Midwest, and even sometimes the West Coast, like Rodney showed. I suppose if the upper air pattern or flow is just right, we could conceivably get some smoke from Hawaii if it took the right track. But for the most part, smoke being carried across the country really depends on the jet stream pattern. The smoke rises, obviously, because it's less dense than the air, gets caught up in the jet stream and is, pushed eastward for the most part. So it really, and John, Rodney and Bill, feel free to jump in too. Really just kind of depends on the jet stream pattern. A lot of times in the warmer months, it's pretty much west to east. So that favors us getting smoke from, the western U.S. and a lot of times southern Canada as well. But I suppose, if it was a big enough fire and there was enough smoke, we could get some from parts of the Pacific as well. I think that's probably certainly lesser of a chance, maybe in the western U.S., but a little tougher to do here in the east. So, Bill, Rodney, I'll let you add anything to that.
Yeah, I mean, I think you pretty much covered it, Joe. I mean, the only other thing I can think of too is, you get a lot of it's from the jet stream, but for smoke to get down to the ground too, you kind of get different mixing of the air as it's higher up, depending on the temperatures as you're going higher up in the atmosphere, and that's how you can kind of get the smoke to mix down. It's that's when you're usually starting to have those air quality issues or visibility issues when the smoke starts to get down.
Yeah, I think Bill and Joe covered pretty much everything.